In this video, we will be simplifying radical expressions involving fractions. To begin, let's review two important properties that we will use to simplify. The multiplication property of square roots states that the square root of a times b equals the square root of a times the square root of b, if both a and b are greater than or equal to 0. The division property of square roots allows the square root of a divided by b to be written as the square root of a divided by the square root of b, provided a is greater than or equal to 0 and b is greater than 0. Let's take a look at an example. We want to simplify the square root of 9 over 4. We'll use the division property of square roots to rewrite this as the square root of 9 divided by the square root of 4. Well, we know the square root of 9 is 3 and the square root of 4 is 2, so this is just 3 over 2. Great, let's try another example. You may have noticed that the first example contained a numerator and denominator that were both perfect squares. Let's try an example that does not involve perfect squares. Here we want to simplify the square root of 50 over 45. I don't know the square roots of either of these numbers, but wait, 50 over 45 isn't simplified. So let's reduce this fraction before we continue. 50 and 45 are both divisible by 5, so we can rewrite this as 10/9. Great. Now we'll apply the division property of square roots to get the square root of 10 over the square root of 9. We know the square root of 9 is 3, but what about the square root of 10? Well, 10 isn't a perfect square, but does it have any perfect square factors? Well, it's not divisible by 4 or by 9, and all other perfect square factors are too big, so this can't be simplified anymore. The square root of 50 over 45 simplifies to the square root of 10 over 3. Let's go through another example together. We want to simplify the square root of 125 over 2. 125 is a pretty big number. I'm not sure if it's a perfect square or if it has any perfect square factors. Well, one way to easily see this is to find the prime factorization of the number under the square root. 125 equals 5 times 5 times 5. Now we can apply the division property of square roots to get the square root of 5 times 5 times 5 all over the square root of 2. Let's group the perfect square factors in the numerator to get the square root of 5 squared times 5 all over the square root of 2. We know the square root of 5 squared is just 5, so we can rewrite this as 5 square root of 5 all over the square root of 2. This is not our final answer, however, as we don't want to have roots in the denominator. To get rid of the root in the denominator, we rationalize it. But what does that mean? Well, we would like to not have any roots in the denominator, so what's something we can multiply the square root of 2 by in order to get rid of the root? That's right, the square root of 2. Because the square root of 2 times the square root of 2 is just the square root of 2 squared, which of course simplifies to 2. Great, but we can't just multiply the denominator of the fraction by a number. That will change the value of our fraction. So instead, we'll multiply by the square root of 2 over the square root of 2. This is the same as multiplying by 1, so we won't change the value of the fraction, and we'll get rid of the root in the denominator. So let's do it. Applying the multiplication property in the numerator, we get 5 times the square root of 5 times 2, and in the denominator, the square root of 2 times the square root of 2 becomes the square root of 2 squared, which of course simplifies to 2. The last step is to simplify the numerator by multiplying 5 times 2 to get 5 root 10 in our denominator, so our final answer is 5 root 10 over 2. In our next example, we want to simplify the square root of 50 over 75. Both of these are bigger numbers that are not perfect squares, so let's find their prime factorizations. 50 equals 2 times 5 times 5, and 75 equals 3 times 5 times 5. We can cancel the 5's in the numerator and denominator, as they are like terms. This gives us the square root of 2 over 3, or the square root of 2 over the square root of 3 by the division property. Like our previous example, this is not our final answer because we don't want any roots in the denominator and must rationalize it. Since we want to get rid of the root 3 in the denominator, We'll multiply our fraction by root 3 over root 3. The numerator becomes the square root of 2 times 3, and the denominator is the square root of 3 squared, which is just 3. Since the square root of 2 times 3 won't simplify any further, let's multiply it back together. So the square root of 50 over 75 simplifies to the square root of 6 over 3. Our final example looks a bit different because it involves a variable. We can assume that our variable f is greater than 0. Let's start by applying the division property of roots to get the square root of 7f to the 7th power over the square root of 25. We know that the square root of 25 is just 5, but what about this numerator? Well, let's rewrite it as a product of perfect square factors. We can rewrite f to the 7th power as f to the 6th power times f. That gives us the square root of 7 times f to the 6th power times f all over 5. Now, since f to the 6 is a perfect square factor, let's split up the root in our numerator as the square root of f to the 6th power times the square root of 7f. To find the square root of a power, we simply divide the exponent by 2. So, the square root of f to the 6th is f to the 3rd power. So our final answer is f to the 3rd power times the square root of 7f all over 5. Great job working with radical expressions involving fractions. Thanks for watching.